To start off these notes, I would like students to have out the handout that I have shown on the smartboard right now. Again, where it says molarity. As you are getting out that sheet, we have talked about how to make a solution. You have a solute dissolved in a solvent, you make a solution. We've talked about how some things are able to mix, other things are not. We've talked about how to speed up the rate at which things are dissolved or not. What we now need to go over is how some solutions have more solute in it than others. For example, I have up on the smartboard right now, if it was a red dye solution, this one on the far left would be considered to be very dilute. The one on the far right would be very concentrated. And that's what I mean when I say not all solutions are made equal. Another way to think about it, if you are a coffee drinker, some people like to add a teaspoon of sugar to their coffee to sweeten it up a little bit. Some people like to add more than a teaspoon of sugar. The concentration of sugar would vary between these two examples significantly. When we talk about a concentrated solution, again, that could be a colored solution like the blue that I have shown here. Again, a diluted solution versus a concentrated solution. But I like the microscopic view to show you here, as we introduce this term molarity, what does it mean to be concentrated? Some solutions have more solute than others. What we can do is calculate the molarity of different solutions based upon how much solute, how much stuff they have dissolved in water. On the top of your worksheet, it should give a definition of molarity, which again, molarity is just your numerical measurement of the concentration of a solution. The unit for molarity is a capital M. Also on your sheet shows you how to solve for molarity, or what does it mean. Molarity is the moles of solute, remember that's the thing being dissolved, divided by the liters of solution. Now this, similar to other things that we've done throughout the course of this year, is an equation with three variables. And like other three variable equations, we could solve for any of those variables, which is why we're going to go back to our handy little triangle to help out. So this is something I'd like you to write at the top of this sheet of paper. Moles will be on the top. Molarity and liters are on the bottom. Recall how this triangle works. Is if you cover up a variable, let's say I cover up molarity with my hand, that would be moles divided by liters. That's what this is right here. If I cover up liters, it's moles over molarity. And lastly, if I covered up moles, it's molarity times liters. Also recall that moles is very common. However, what's more common is grams. You will need your periodic table as we're working on this as well. So as we approach doing the first problem on that practice sheet you have out, hopefully, besides that sheet, you have a calculator because we're about to do math. You also have your periodic table because mole conversions are going to be involved. Maybe the polyatomic ion sheet would be a good thing to have as well. So if the sub needs to take a minute now to pause the video so everyone can have everything ready, once we are ready, we are going to start with this question number 1 below. So I show a sample problem on the top. I am going to do question number 1 right now. Question number 1 says, what is the molarity of a 5,000 milliliter solution containing 22.95 grams of KBr? Just like I've shown up above, I need to figure out my moles and divide it by my liters. Again, that is our equation. So, to start off with, I'm going to write down 22.95 grams of KBr. And I'm going to use my periodic table to convert to moles. Take the mass of K, add to the mass of Br, that gets me 119.00. My number of moles would be 0.1929. Molarity is moles per liter. So if I'm given 5,000 milliliters, I need to convert that as well. 5,000 milliliters, there's 1 liter for every 1,000 milliliters, which means I have 5.000 liters. Here's the good news, ladies and gentlemen. If you are someone who can do milliliters to liters in your head, metric conversion, we do not require that you show this conversion anymore. Again, if you can do metric in your head, you feel free to do so. However, you will still show your mole conversion. You will still show the next step, which the next step is, in order to solve for molarity, I need to take my moles divided by my liters. And as always, you will show a final answer with the correct number of significant digits and a unit. So, take my 0.1929 moles divided by 5.00 liters, and I get 0.0, remember those zeros don't count yet for sig digs, 3857 capital M for molar. Sorry for writing sideways, but you can see I've run out of room on the left-hand side. Step 1 for your calculations that you need to work on is find the moles, find the liters, moles divided by liters equals molarity. That is my final answer. What I would like to do right now is have the video paused, and students will work on questions 2 and 3 at the bottom of this page. After about 5 minutes, the substitute teacher will hit play, and I will show the answers to questions 2 and 3. You can see here are the answers to the 2 questions on the bottom of the board, or on the bottom of that sheet of paper rather. Again, I abided by sig digs. I wrote down my unit of capital M, but I also wrote down the formula. Let's flip to the back side of the sheet of paper. And on the back side of the sheet of paper is a problem where you are solving for the grams. If I know the molarity, if I know the volume, what can I now find? Here's molarity given to me. Here's volume. The question is asking for grams. Remember our triangle, which I wish I would have drawn a little bit bigger just now. Moles, molarity, and liters. In this particular problem, we are solving for moles to start with. Moles would equal molarity, 0.27 molar, times liters, 1.95 liters. Once again, if you need to use a metric conversion, it is 1 liter for every 1,000 milliliters. However, we've decided that that step no longer has to be shown, but the rest of your work should be shown. I've just taken molarity times liters to get me 0.53 moles. I start with 0.53 moles of RBI. If the question asks for grams, I can do a mole conversion. Grams would be on the top because that's what I want to solve for. And moles would be on the bottom in order for units to cancel out. Look at the periodic table. There are 212.37 grams in 1 mole of rubidium iodide. Multiply. Report with 2 significant digits, which is why this answer is 110 grams of the RBI. So once again, a second way you can do a molarity problem is if you're given the molarity and the volume, you could solve for moles and then use your periodic table to solve for grams. Remember to read the question and kind of like what you saw that I just did, annotate the question. Identify what variables are you given. Identify what variable you're trying to solve for. Then you can use that little triangle to help out. Just like on the previous side, I'd like the substitute teacher to pause the video at this time so students can work on questions 2 and 3 at the bottom of this back page. After they are ready, we can unpause the video and reveal the answers. Notice in question 3, it didn't even ask you to solve for grams. It just asked you to solve for moles. It made that question a little bit easier. Question 2 might have been tricky because barium peroxide, the formula is kind of tricky for that one as well. Speaking of tricky, if there is time, and again, the substitute teacher will determine that based upon where we're at in class, so you have time for the quiz. The one type of problem that I did not have you try to solve for right now is one where you'd solve for the volume of the solution. And that's what this challenge question states. What volume in milliliters of 0.253 molar solution can be created using 42.8 grams of copper 2 nitrate trihydrate dissolved in water? If you have a scrap sheet of paper or on the sheet of paper you're already working on, room to try to solve this, what I would suggest doing is first figuring out the formula of copper 2 nitrate trihydrate. Then do a mole conversion. Start with your 42 grams of solute, convert it into moles. Now you have moles and molarity. If you remember our triangle, moles divided by molarity will get you to liters. And from there, you can convert to milliliters. That is a mouthful of a problem. But once again, if you want to take a minute or two to try to solve this, the substitute teacher can pause the video if we have time. Here is the final answer for that problem. Your homework tonight will have 3 questions where you need to solve for the molarity. It will have 3 questions where you need to solve for the number of grams. And it'll have 3 questions where you're solving for the volume of the solution. And that completes our audio notes on how to do molarity calculations.